Hello everyone, and this is going to be homework 1, part B, from what I think is maybe the 11th or 12th try. So let's read part A. So B1, a container with a volume of 0.1 meters cubed contains 1 kilogram of liquid water in the air with a headspace of 1001,325 pascals and 298 Kelvin, and that is then sealed. So to what temperature should this container be raised to so that the final pressure is 200 kilopascals? I wanted to say Kelvin for some reason. Derive and explain the pertinent equations. So first, we have to kind of break it down in your head, or you can write it down. The best way to think about this is there's two different pressures that we're going to be calculating. There's going to be the pressure of the liquid, and there's going to be the pressure of the air. And so let's start writing down our variables. So homework 1B, oh, that's not supposed to happen. Anyway, it says that the pressure that we want, or the final pressure, is 200,000 kilopascals. And then, so, as I said earlier, we're going to break that down into two different steps. We have our final pressure, and then our pressure saturation value, and the pressure of our vapor. So, and then we also, going from there, we have our total volume, and the amount of mass that our liquid is, in which, using the density, we're actually able to calculate the different masses, or the different volumes inside. We have our initial pressure, and then we have our pertinent things. Our temperature, our R value, and then just the equations. So first, let's start with the pressure saturation. However, pressure saturation is actually an equation which needs temperature. And so to do that, you're going to have to define that as a function. So we're going to define pressure of vap as T, like that. Okay? But to get this, there are certain values that we can use a certain equation to figure this out. And that equation is the Hw1PartB equation. Sorry, my French is bad. And so, as you can see here, for the pressure, again, I want to point out units. Units are important in this. The equation would be 10. Let's find an equation up here. I don't like these. So it would be 10 to the power of A minus B over temperature in Celsius plus C. And again, units. So let's write out this equation. So it's 10. Ooh, wait, before I saw something, I messed up again. It needs to be uppercase T. So we have 10 to the power of, we're going to call it PVAP A minus PVAP B divided by, so this is going to be two different, we're going to separate this inside of here because of temperature, minus 273.15 as our, let's look back at our variables, as we are in Kelvin and they want Celsius. So we have that. Now we're going to subtract by PVAP C. And then that closes it out. Good. But we don't have any variables. So let's write those out real quick. So PVAP A, PVAP B, PVAP C. Now let's bring over our variables. So we have this. And something I want to make sure we are aware of is the temperature parameters. These will be important later, but this is just something to make sure you keep in your mind as things are allowed to change. And if you notice here, we have our units of measurement are in Kelvin, which we took care of in the equation, and pascals. And here, it's millimeters per mercury, which is not what we have. And so to convert that, we would multiply by 101,325 and then divide by 760. And so let's make sure whatever we have is working. So we're going to do PVAP, and then what should we use? Let's use 298 just for the fun of it. One thing I do, ooh, it's loading? Oh, I didn't save this. And then I actually have to save that too. I think my Wi-Fi has been cutting out too, which is never great. Sorry. Let's see what's going on with this. Why isn't it not reading out? So T parameters any. Function. Okay. Let's try it under here real quick. Oh, I know why. I never put return. So it would just do it once and then take it. So save that. There we go. And that doesn't seem right to me. So let's look. I mean, we can come back to this if it comes to it. 273. Actually, that would make sense, as this would be really small. So it would be a, or 10 to the power of a minus b divided by almost 0. Yeah, anyway, let's just leave this alone. So now that we have our first pressure, we have the illustrious job of finding our second pressure. And so to do that, well, my hands are cold. Let's start writing down different variables that we know. So to affect this, we know our temperature, which is 298. I'm going to put kelvins. We know R is the constant everyone dislikes. We know our pressure initial. And okay, and we know our volume total. Oh, I should probably get something there, 0.1. Then we know our mass of the water, which is 0.1. And we are actually able to calculate the moles, or we're going to be able to calculate the volume, which will then lead us into the moles, as that has everything we need, as we have R, T, P, and V. We don't have N here, so we need to calculate that. First, to get the mole of air, or the vapor, we're going to need the volume. And so to get the volume, you would have there, my favorite thing, equals, let's see, 0.1, not 0.1, we can do PIV minus M water divided by 1e to the 3, otherwise known as the density at these units. Now I just want to check the units real quick. Oh, I used pressure, silly me. Pressure, not V total. That explains why that's very off, huh? There we go. So now let's calculate the moles of the air, which would equal V air, right? So it's pressure times volume, so times PIV divided by R times T. And so if we're right, this should be around 4. Now, let's look. Okay. Just want to make sure everything I have is correct. I didn't put period by. Let's see, what's the issue? So, expected member name. What I was trying to do was make this a float, or, oh, you know what? I messed this up. The mass is 1 kilogram, right? Oh geez, that's not what I want to do either. Son of a gun. One period. So this is just to make sure the integer changes. Okay, it's save everything. And it's not broken yet. It's always a good sign. Okay. So now that we have our moles, we have our V air, we are actually able to calculate our final pressure. Except one thing, I realized to calculate it, we need to use root from up here. And to use root, we need to set it to 0. To set it to 0, we're going to add our Fp1 equals 200 e to the 3. And this is our pascals right here. So we're going to define, what should we call this? We're going to call it Hw1PartB. Respect to t. Now we're going to return. Ooh, man. Okay, let's write this equation. We have our p with respect to t. I don't know why it always goes lowercase for me. I swear I'm hitting shift. P with respect to t plus n air times t divided by r times v air. Not pt, p vap. All right, so we have that here. And what else do we need? So this is our first pressure up here. Now we're going to calculate our second pressure. So it would be P T over V. And now we're going to subtract our final pressure, Fp1. And I did not make, what? Oh, yeah, that's funny of me. I put it here instead of here. So now we would do root of Hw1PartB and our guess for the equation, which we're going to put as 350, and we are going to get, ooh, let's look. Theorem, it says float object is not callable. So we're going to say without the t. And it was solved. And that's not a good answer. So let's go through and try and decode or debug it. I think it happens to be that I put the temperature wrong. Our temperature is 298, not 293. That might be why there's a slight change in what I would expect the answer to be, but it wouldn't be that big of a difference. So it says it converged, but it's a very, very small number. So let's go through again. Okay. Okay. It's good. 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 Which leads me to believe there's something wrong with PVAP. So let's try 298 again. So PVAP of 298, excuse me. Yeah, that's something wrong with that. That's a little bit of a big number, wouldn't you say? So we have that. I think it happens to be that I wrote the equation wrong, and it's supposed to be plus C and not minus C. That would, I would think, would have a big issue with what we're doing here. There we go. That looks a lot more reasonable instead of something to the whatever it was. And well, looky there. We have a value for K, or for our temperature, for which this would all work. Excuse me. However, if you realize it's 392, which converts into Celsius as something over 100. It really messes up with our parameters. So if this was something we would need to continue constantly, I would set up an if structure. But for now, I'm going to change it manually and just hand change. Which I don't understand. I think it would be difficult to actually make an if structure for something along these lines. As for the fact that if it's all depending on this, it would have to have like be in a really big loop. So that would be interesting. as I'm not a Python aficionado, as this is my 12th time doing this, so that should be obvious. So like through there, and we get 393. Mwah, that sounds perfect to me. So now let's look at part 2. Or part 3, excuse me. So we're going to repeat the calculations of B1, which means we're going to keep this. However, the only change is that the volume total is going to be unknown, but we have a set amount of moles of water vapor that we would like. However, there is something I'd like to see real quick. So if volume total is unknown, for volume total, that means we're not going to be calculating it like this, or up here. We're going to be calculating it down here. So if we have 2 unknowns, that means we're going to have a different way of solving it. And so a way I was taught to solve it would be in a vector. So we're going to call this fun3, because we always are having fun. Vec. And voila. So now we need to have it in an order that we're going to follow for the rest of us. So it's going to be v total, as that's something we don't know now, as it's a new variable. And we're going to have temperature equals vec. And something I found out through trials and tribulation is that if t is on this side, you get a whole crap ton of issues. And again, we have to add one more thing, as we have a new value of the n mole or n air that we want, which is 0.3. Let's check real quick. 0.3 moles of water vapor. Okay. So now we have to redo the equations inside of here that are respective of v total. So we're going to have to redo the air, I believe. And we're going to have to bring down n air, I wanted to say. Solve that. Okay, so far looks okay, like it's going well. Now, for the fun part. We get to write our equation. I feel like I'm missing something. There should be a return value, I would believe. Anyway, let's keep going. So we are actually going, as all what this is doing is keeping our values into a vector. So now we're going to calculate certain things. So we're going to, I want to say we would create another function, but I'm not all too sure. So if we were to create another function, it would be with respect to t, obviously. And we would have these. Anyway, let's try that. So we're going to def fun4 with respect to t. And inside of that, what we're going to do is we're going to use brackets. First, let's return. So this is going to be changing. Now it's going to be in brackets. And we're going to have to calculate different things in different areas. So on the right is temperature, which is a vector. So all we're going to do is bring this down, as this is calculating the temperature the same as it is above. However, there's a few small changes. But over here, on the other hand, we are going to be calculating pvat, I believe. So it's going to be pvat t, and we're looking for calculating for moles, I believe, because it's asking for here. So it's going to be that plus, now we're going to do, looking for moles, it's going to be, I want to say, let's go through this real quick, give us some room, and look at this. N, so it's going to be pressure times volume, so plus P initial times var. What did I call P initial? So you say that variable is not defined. I call it P if, okay, initial vapor, okay? divided by RT. Oh yeah, multiply that. So now we would see if this is broken. It's not broken yet, but you have a little faith of root function, or fun4, comma brackets as what we have as an effector. So our guess for the volume was going to be 0.1, and then it's going to be 350 Kelvin as our guess of last time. So, okay, so there is a mismatch between here, which makes me think I'm not supposed to have this. So let's try that. And, ooh, I also forgot to subtract by the n air want. So let's try fun3 and see if this breaks anything now. Okay, so we get we get the right over here, but we don't have the right here. So let's see if I made a mistake here and multiplied by that. Okay, this is getting a lot better. This is getting a lot smaller, which is what we want to see. So we have that. Good, 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 good. Okay. There's probably just one small thing that I've changed, or it's not exact, which will bring everything down. So that, let's try 0.01 and just see how that changes things. Okay, it doesn't change anything at all, which is good. So pressure times volume. Let's look down over here real quick. So V air. So the left and right equation is our Psat times our V air. So let's see what happens if we get rid of this pressure, because again, I wasn't sure which pressure to use as depending on the pressure. Oh, oops. So why is it? What's the error? Closing parentheses. That's closed, and then here. So let's see what happens to that. Let's see what happens. Ooh, I don't like that. Happens to that. And from here, my issue was I was using pressure initial when I should have been using the total pressure of the evaporation phase of the vapor phase. And so this ends up getting the value we want. So I hope you had a fun time. I know my hands are freezing, and I will see you on the next code.